So a direct variation equation looks like this. Y equals kx. So a direct variation equation is a special type of equation that kind of has this form, y equals kx. Now when I refer to k is just a number. So k is a number. So it might look like y equals 2x, or y equals negative 5x, or y equals 6x, or y equals 0.5x. It doesn't have to be a whole number. It can be a fraction or decimal. But k is just a number. When I refer to k, there's a couple different things I could refer to k as that you're going to see it referred to. One thing, k is going to be the constant of variation. So there's like 3 words that you're going to see k referred to as. Constant of variation. That's one word you may see it referred to as. What number? Constant means a number. What number am I varying by each time? The same, yes, because it's a constant. So we're keeping it the same. It's a number. We're going to be varying by the same number each time. You may also see it referred to as the rate of change, which is what we talked about Tuesday. So constant of variation, rate of change, and the last thing, rate of change is the same thing as what? Slope. It also may be referred to as slope. Now we haven't really talked a whole lot. I mean, we talked about slope Tuesday some, but we're going to kind of talk more about slope in Chapter 4. Chapter 3 is a short chapter, and Chapter 4 is a shorter chapter, so they kind of cover the same stuff, so we're combining them into one test. So k is a number, and it's called the constant of variation. It's also called the rate of change. It's also referred to as the slope. So it's 3 different things. So we're looking at equations, working with equations that looks like this. Y equals 2x, y equals 1.5x, y equals negative 5x. Okay? So we're going to graph them, we're going to create equations, we're going to work with them. Those are direct variation equations. First example, I give you a graph. Name the constant of variation for each equation, then find the slope of the line that passes through each pair of points. So, first of all, what type of equation is this? Or what type of function is this? Look at the graph. Linear. It creates a line. Do not overthink this. If it is a line, if the graph is a line, this is a linear function or linear equation. So first thing they ask for, name the constant of variation for each equation. So if I look at the equation, I want to name the constant of variation, which I'm going to COV, constant of variation. As I look at the equation, what is the constant of variation? Negative 4. Look at your equation. The constant of variation is the number in front of x. So your constant of variation is negative 4. Have I answered the question? No, I also want to find the what? I want to find the slope of the line that passes through each pair of points. How do I find the slope if I'm given 2 points? You can do rise over run. That's fine. So I could start with my left point and do rise over run. So I go down how many? 1, 2, 3, 4. So that's a what?
-4.
And I go across, I run 1. So that is negative 4. So you can do it rise over run, that's fine. What's another option to find the slope?
y2, y1.
y2 minus y1 over x2 minus x1, like we did on the warm-up. Either option is fine. Y2, let's choose to be 0. So 0 minus the first y, which is 4. So 0 minus 4. Yes?
What is that besides the y at the very end?
Here?
Yeah.
It's a 1. Y2 minus y1.
Right.
You're good. So 0 minus 4 over 0 minus negative 1. So negative 4 over what? 1. Plus plus 0 plus 1. 1, which is negative 4. They all three are the same as negative 4 is. Hard to see. They all three are the same. That's what you should notice. So the constant of variation, look at your equation, it's the number in front of x. Then find your slope either by using the rise over run or by using the slope formula. I don't care which way. Okay, any questions on that one? Okay, let's look at B. First thing I want to know is I want to know the constant of variation. So if I look at the equation for B, this is a linear equation because it's a line when I graph it. If I look at the equation, what is the constant of variation? 1/2. This is not rocket science. Constant of variation is the number in front of x. Look at your equation, it's a 1/2. It will never be behind x. But it's the same thing. It's what's being multiplied by x. So if they would randomly put it behind x, it'd be the same thing. But you almost will never see it behind x. Okay, now let's find the slope. You can either find the slope by doing rise over run or using the slope formula. So as I look at it, they give you this point 0, 0, and they give you the point 0, 3. 6, 3, sorry. 6, 3. So rise over run. I go up, how many? 1, 2, 3. I go up, so that's a positive 3. And I run, I go over how many? 4, 5, 6. Positive 6, so I went to the right. 3, 6 reduces to 1/2. What do you mean?
The 0.63 and the fraction is 3 over 6.
Yes, because I go through 0, 0. Yes, so yes, but not always, but only because I go through 0, 0. So your slope and your constant of variation should be the same. And if you wanted to find the slope using y2 minus y1 over x2 minus x1, that's fine with me too. Okay, any questions on that? Are we good with that? These are direct variation graphs. Now, if I look, what do you notice about these two graphs? These are direct variation graphs. What do you notice similar about both of these graphs, or both of these lines?
0.
They what?
They both go through 0.
That is a characteristic of a direct variation equation, that your line will go through 0, 0. So as I look at example 2, I give you the equation. Now I want you to actually graph it for me. So first thing you need to graph is you need to graph 0, 0. So a direct variation equation, one that looks like y equals a number times x, and that's it. Y equals kx. Will always go through 0, 0. So when you're graphing these, the first thing you want to graph is 0, 0. So we're going to put a point at 0, 0. Always for direct variation, they go through 0, 0, which makes your life a little easier. Next thing you find is you find k. And what's another name? K is my constant of variation. What was another name for k? Slope. That's fine. Good try. So as I find k first. K is the same thing as my slope. So as I look at my equation, what is k? 2/3. So if k is 2/3, that means my slope is 2/3. So if I know I have the point 0, 0, because every direct variation will go through the point 0, 0, and I have a k value or a slope of 2/3, how do I get the next point? Up to? Right, 3. They're both positive. Positive 2 and a positive 3. So I go up 2, right 3. I have to have 2 points to graph a line. How else could I get another point? If I went up 2 and it got me off the graph, how could I get another point and still keep it positive? I could go down 2, which is negative, so I'd have to go, which direction 3? Left. So you can also do double negatives. You could go down 2 and left 3 because 2 negatives make it a positive. So either way, so if you would go up 2 and it would be off the graph, then you would want to go down 2, left 3.
When we did it in middle school, we would just keep going until we did get off the graph.
Oh, well, I don't really care. You only need 2 points. So how do I know, why does this line make sense with having a positive slope? It's going up, uphill. So you can always check it. It's an easy way to check it. If my slope is positive, it should be going uphill. Any questions on that? Can we do this? Yes. Okay, let's look at B. As I look at B, Why do I know B? First of all, why do I know B will be a linear equation? We talked about identifying linear equations in 3.1. Why will equation B be a linear equation? Look at 3.1, the very first thing, very top of the packet for 3.1. We talked about how do I tell whether an equation is linear?
3.1.
Huh? 3.1, very first, like very top of the note packet.
X and Y have a degree of 1.
X and Y have a degree of 1, and they have to be added or subtracted. Do X and Y have a degree of 1? Degree means the highest exponent. Do X and Y have a highest exponent of 1? Yes, there's no exponent there, so it's 1. Now, I could add 5x, and they would be added together. So this is linear. So I know it's going to create a line. Let's go one step further. Is it a direct variation linear equation?
No.
Okay, what's direct variation? It looks like what? Y equals kx, a number times x. Does this look like y equals a number times x?
Yeah.
Yes, so this is a direct variation. So what point do I know it's going to go through? 0, 0. If it looks like y equals a number times x, then I know it goes through 0, 0. And we'll talk more about it in chapter 4. So I can go ahead and graph the point 0, 0. It makes your life pretty easy. Next thing I need to find is I need to find k, which is the constant of variation, which is the same thing as what? Slope, which we'll talk more about in chapter 4, but we're just kind of getting you introduced to this. What is my k value? Okay, which is also slope. If my slope, or k, is -5, how do I find my next point? 1, 2, 3, 4, 5, down 5. Why do I know I go right 1?
Put a 1 under the 5.
Because any whole number you can write as over 1. So down 5 gets the negative, and I have to go right 1 to get the positive. How could I get another line? 1, 2, 3, 4, 5 gives me a positive 5, so I need a -1. My line is going downhill, which makes sense because my slope should be negative. Draw your line all the way through the graph.
Terrible.
Don't judge me.
No, my line.
Okay. Okay, any questions on this? Okay, let's look at some story problems. We need to make it a little trickier. Good for you.
No, they're not.
They are good for you, I promise.
It's proof factor. If someone reads too much, they can die.
Do it?
If someone reads too much, they can die.
Okay, well, you tell the state of Indiana that when they give you that step. Okay, example 3. Suppose y varies directly as x, and y equals 72 when x equals 8. Multi-step question. Listen up. We're almost done. We just have this page to get through. First thing, write a direct variation equation that relates x and y. Guys, listen up. You write a direct variation equation that relates x and y. Use a direct variation equation to find to find x when y equals 63. First two parts. Write the equation and then find x. So write the direct variation equation. It's the first part. And then I need to find x. So, first thing, we need to find the direct variation equation. First thing I need to do is I need to find k. I need to find the constant of variation. If I tell you y varies directly, what will my equation look like? If it's a direct variation equation, what's the basic setup going to look like? Y equals kx. If it tells you y varies directly, that means it's a direct variation equation, so I know it's going to look like y equals kx. Y equals a number times x. First thing I need to find is I need to find k. Look at the information they give you. How can I find k with the information they give you? Read it, figure it out, because it's kind of the thought process you have to use. With the information they give you, how can I find k?
Plug in 63.
No, because that would only be plugged in for y. And then I will still have a k and an x left, so I couldn't find k. Keep looking at it. With the information they give you, how can I find k? Plug in what? Okay, plug in 8 for x. And plug in what? Well, is it 62 or 70? Is it 72 or 63? Look at it. This is important. You have to use the two that go together. Suppose y varies directly as x and y equals 72 when x equals 8. You have to use the two values that go together. Does that make sense? Okay. So you have to use the 72 and 8 because they go together. It's y is 72 when x is 8. So start with your equation, plug in the x and y value they give you, and then how do I find k or solve for k? Divide by 8. 72 divided by 8? 9. So 9 equals k. Have I answered the question?
No.
I want to write the equation. So how do I write a direct variation equation if I know k is 9?
9 over 1.
Nope. How do I write a direct variation equation when I know 9 is k?
72 equals 9.
What does my direct variation equation look like? Y equals a number times x. If I know k is 9, how do I write my equation?
Y equals
9x. So I want the direct variation equation that looks like y equals a number times x. So you take your k and you put it in where k is, y equals 9x. That's the first part. Any questions on that? The second part, use the direct variation equation to find x. Stay with me, guys. Use the direct variation equation to find x when y is 63. So this is the next part. If I want to find x, I'm going to be solving for
Y.
If I want to find x, I'm going to be solving for x. So if I set up my equation, I need to plug something in to be able to just have x left. 63 equals 9x. I want to find k when y is 63. Sorry, I want to find x when y is 63. Y is 63, plug it in. 63 equals 9x, solve it for x. Divide by 9, 7 equals x. Did I answer the question? Did I find x?
Yeah.
X is 7. So here's your equation, y equals 9x, and I found x to be 7. Any questions on that one? You've never done it before, but it's doable. Okay, let's look at the next example. Suppose y varies directly as x, and y equals 98 when x equals 14. Write a direct variation equation that relates x and y, then find y when x equals -4. What are the two things I want to know? You need to write this down. Get a piece of paper. I said that. Okay, there's some up there. Okay, what two things do they want on this one? What two things do I want?
Write a direct variation equation that relates to x and y, then find y when x is -4.
Okay, two things. Write a direct variation equation, then find y when x is -4. Okay, let's start with the first one. Direct variation equation. If I'm writing my direct variation equation, what's the first thing I need to find?
Okay.
Find k. So we need to find k first. It says it varies directly, so I can start with the y equals kx formula. Because it says write a direct variation equation, so I can start with y equals kx. I need to find k. How do I find k with the information they give me?
Plug in 98 for y and 14 for x.
Plug in 98 for y and 14 for x. You have to use the two numbers, the two x and y values that are related. So y is 98 when x is 14. divide by 14. Once you plug it in, it's an easy equation to solve. 98 divided by 14, 7 equals k. Have I answered the question? No, I want the direct variation equation. So my equation, if I know k is 7, will be y equals 7x. Direct variation, y equals a number times x. That's the first part. Any questions on that? Second part. I want to find y when x is negative 4. So if I use my equation I found in the first part, y equals 7x, I want to find y. So I'm going to get y equals a number. And how do I do that if I know x is negative 4?
Times 7 by negative 4.
Plug in negative 4 for x. Negative 28. So the math is not hard. You guys can plug in numbers. You can solve one-step equations. It's just being able to understand what we're doing with this. Thank you. Tabitha, if you want to wait after notes, we can go. It says when convenient. Okay, any questions on those? Okay, let's look at a couple story problems. Example 4. A hot air balloon height varies directly as the balloon's ascent time in minutes. First one. Write a direct variation for... Guys, I'm literally talking, so don't talk. Write a direct variation for the distance d ascended in time t. So you have to be careful when you read this. A hot air balloon height varies directly. And I want to write an equation for part A. So what would my direct variation equation look like?
Y equals dt.
Okay. Well, first of all, if it's a direct variation, it's going to be y equals kx. However, my variables are not y and x. What are my variables? D and t. So if the balloon's height varies directly as the balloon's ascent time, the height varies directly with the ascent time. So which variable represented the height? D. So D equals K times what? T. So you have to read it. Logan, keep your head up, please. You have to read it carefully. It will tell you this varies directly as this. So the balloon's height varies directly with the ascent time. So the balloon's height, which is represented by D, varies directly with the time. So D equals K times T. You still have to have K in there. It still is going to be K equal, or it's K times a variable. So D equals K times T. Okay, any questions on that? Okay, now, okay, next thing it wants me to do is it wants me to graph the equation. So I'm going to make a graph out here. Okay, let's label my axis. What's going to be my x-axis? Which variable represents x? T.
Oh, T.
It's in the same spot as x. So T, so that is time, so that is going to be my x-axis. What represents my y value? Distance, D, so that is the distance. Okay, I need to graph this. How do I know how to graph something?
You don't have any numbers yet.
I know, I'm looking, just a second, yeah. Did I not type in something? Yeah, let me look in the book, just a second. As I'm looking at it, I was confused. Take a break, 2-minute break. Round 2. I think I forgot. Yeah. Oh, there's a picture. That's what. Okay. So open your textbook. Listen up, guys. Open your textbook to page 184. There's a picture I forgot to put on there, which will help us.
Okay.
184. If you don't have your book, this is math class. You're expected to bring it every day. Okay, so get out your Chromebook and get online and get it. Then did you ask?
Yes, I did yesterday. You
Did
said
you?
it's not my problem.
Did you ask after that? I'm sure if you would ask after class, because you asked in the middle of class, I would have gotten it for you. I also gave it to you at the beginning of the year and told you to write it down.
No, I didn't.
Okay, so we are looking, then scoot over so you can see it in someone else's book. Don't sigh, because it's not my issue you don't have your book.
See, that's what you said yesterday.
Okay, because it's not my issue. It's not my responsibility. You're a freshman in high school. Okay, so as I look at page 184, there is a picture to the side. So the issue is, when I try to graph this, I don't have any numbers. So I don't really know where to start. But as I look at the picture, what does the picture tell you?
Which picture?
To the right. So page 184, example number 4. There's a picture to the right of it.
Oh.
What's that picture tell you? Hot air balloon.
350 feet and 5 minutes.
So the distance is 350 feet, and the time is what?
5 minutes.
5 minutes. So, just like the ones we just did, it will tell you two things that are related. So instead of saying x is this and y is this, it will tell you the distance is this, the distance is 350, and my time is 5 minutes. So just like the ones we did, I need to find k first. So how can I find k if I know the distance is 350 when my time is 5 minutes? Plug in 350 for D. Plug in 5 for T. So to get my equation, I need to get D equals a number times T. Y equals a number times X. Same idea. How do I find K? Divide by 350 by 5. So my K value is 70. Now if I actually write my equation will be what? What will my equation look like? T. D equals 70T. K is 70. It's direct variation, so it should look like Y equals a number times T. Or in this case, D equals a number times T. D equals 70T. Now I want to graph this. What ways do I know how to graph?
Put 0.
Well, what ways do we know how to graph first? Talked about in 3.1. You should have an idea. We talked about in 3.1, so flip to 3.1 if you need to. We talked about 2 ways to graph so far.
We got down the numbers I didn't look.
Yes, we already did that. Okay,
For the graph.
what 2 ways do I know how to graph? Nope, that doesn't really tell me how to graph. I want to know how to graph. 2 ways do I know how to graph? So I want everyone looking at your notes for 3.1 if you're not. Because when I ask a question, I expect you to try to answer it, not just sit there and not care. What are the 2 ways we've talked about how to graph? Yes? No, we kind of did that a little bit, but not too much yet. So we really do a ton of graphing with that. We could do it technically. X and Y intercepts and what? No, that doesn't tell me how to graph. We've graphed using X and Y intercepts, and we graphed using a what?
Table.
Table. Those are the 2 ways we know how to graph. X and Y intercepts in a table. So as I look at this equation, D equals 70t, go ahead and set up a table and graph this real quick. So as I set up a table, that'll probably be the easiest way to do it. X is t and y is d. And we're going to set up a table and graph this real quick. Get two ordered pairs and graph it. What would be easy numbers to plug in for t? I would do 0, 1. Why would negative 1 not be a good choice? And think about it. It would, but why would negative 1 not be a good choice? What does x represent in this case?
Go backwards in time.
Time. X is time. Can I have negative time?
No.
No. So we need positive numbers. We can do 0. If I plug in 0 for t, what do I get back for d?
0.
If I plug in 1 for t, what do I get back for d? So as I graph this, all you need to do is make a table, graph the points. 0, 0, which we know because it's the direct variation, so we really already know it goes through 0, 0. And then let's graph 1, 70. So we can go by 1s for time. You don't have to go do too many of them. And what would be good numbers to go by with the distance? 10. So 10, 20, 30, 40, 50, 60, 70. Whatever, it's fine. Either way is fine. So 170, and there's your line. Now on your homework, you will have a graph given to you, but you could draw it just as easily. Okay. Any questions on that, guys? Stay with me. Any questions on that? Okay. Part C. Estimate how many minutes it would take to ascend 2,100 feet. Now, it's a story problem. Look, what are they asking for? What are they asking for? How many minutes? So what variable do I want to solve for if I'm looking for how many minutes? Look at my equation. T. If I want to know how many minutes, I want to know the time. I want to know t. So we're going to take my d equals 70t, and we're going to solve it for t. Now, to solve it for t, they also tell me what other information. What other information do they tell me? Read it. How many minutes it takes to ascend 2,100 feet. What other information do they tell me? You guys can read the problem. What other information do they tell me?
21,000 feet.
And what does 2,100 feet represent? Distance, which is d. So we could take my equation and we can plug in 2,100 for d. 2,100 equals 70t, and we can find how many minutes. How do I find t? Divide by 70. 2,100 divided by 70. 30. And label it. 30 what? Minutes. The math is easy. It's just getting it set up that's going to be tricky. Now, next question. How many minutes would it take to ascend 3,500 feet? Well, let's think about it. Plug it in. What's my equation going to look like? 3,500 equals 70t. How do I find t? Guys, stay with me. I'm not sure why we're having side conversations.
Divide by 70.
We've taken notes twice. You're not going to have notes tomorrow. Divide by 70. Yes. 3,500 divided by 70, 50 minutes. Why does that make sense? How long did it take to raise 2,100 feet?
30 minutes.
So
It's only 20 more.
So 3,500 is going to be more than the 30. Okay, next one. The Ramirez family is driving cross country on vacation. They drive 3,300 miles in 5.5 hours. Write a direct variation equation to find the distance d traveled in time t. Direct variation, so I'm thinking y equals kx. That's the first thing I think of. They tell me I want a direct variation equation. John, keep your head up. So I'm thinking y equals kx. However, my variables are going to be different. D equals what? No? KT. D equals KT. You have to have a K in there always. So as I look at my variables, find the distance traveled in time t. Distance is going to equal K times how long you drive. K times your time. If I drive 2 hours and I multiply it by my rate, that will tell me my distance. So D equals KT. However, this isn't the full answer. I want the actual equation, so I need to know what K is. How will I find K given the information they give me? Well, first of all, look at the information they give me. They drive 330 miles. 330 miles will be what? D, the distance, equals K times the time. And what's the time?
5.5.
5.5.
So you divide that.
Divide by 5.5. What is 330 divided by 5.5? 60. 60 equals K? Sheldon. So my actual equation is D equals 60T. Okay. Same idea, just with different variables. Next part, I want to graph the equation. We can graph it down here. If I want to graph the equation, okay, my x-axis will be what? Time. The y-axis will be distance, just like the last one. If I want to graph this, make a table. T and D. I need 2 points. First of all, if this is a direct variation equation, what point do I already know? 0, 0. So if you don't want to do work, you know it starts at 0, 0 because it's direct variation. Next one, let's plug in 1. If you want to plug in 2, it doesn't really matter. We can really just need 1 point. If I plug in 1, so D equals 60 times 1, which is 60. This, you guys can do this. You can plug in numbers. You can graph a point. 0, 0, and 1. We'll go by 1s down here at time, and we'll go by 10s. 10, 20, 30, 40, 50, 60. So it's going to be 160. There's my graph. You guys can do this. Make a table. Very, very doable. Part C. Estimate how many hours it would take to drive 500 miles. I want to know how many hours. So what variable am I solving for?
Miles, T, D, T.
You're saying like all of them. How many hours? So look at your equation. Which variable represented hours? Time, T. If I want to know T, and they tell me I drive 500 miles, what does 500 represent? Distance. So 500 equals 60T. I want to know how many hours. I want to know the time.
8.3.
Divide by 60.
8.3.
8.3 hours. Okay? I know this is new, so that's going to be the confusing part of it. Put in the time to do the homework and you guys can get this. The equations are not hard, it's just different. You know how to graph making a table. You know how to solve one-step equations. You guys can do this. Okay? We are doing a worksheet for homework just because there's graphs. So worksheets are easier.